Light is always moving. It travels in straight lines called rays. Sometimes light bounces off an object. We call this reflection. Reflection allows us to see the world around us. It's a fascinating phenomenon. Think about looking in a mirror. You see yourself because light is bouncing off your body. It then bounces off the mirror and reaches your eyes. This is how reflection works. Imagine standing by a calm lake. You can see the trees and clouds reflected in the water. This is a perfect example of light reflection in action. The smooth surface of the lake acts like a mirror. Light from the trees and clouds hits the water. It then bounces off at the same angle, creating a mirror image. The angle of incidence equals the angle of reflection. The study of light and reflection has a long history. Ancient Greek mathematicians like Euclid made significant contributions. He experimented with light reflection around 300 BC. Centuries later, an Arab scholar named Alhazen made groundbreaking discoveries. He studied how mirrors work and wrote extensively about light reflection. His work laid the foundation for modern optics. The law of reflection governs how light bounces off surfaces. This fundamental principle is not just a rule for scientists and engineers. It's a cosmic rule that applies to everyday life. From the way we see ourselves in the mirror to the way light interacts with the world around us, it states that the angle of incidence is always equal to the angle of reflection. This means that when a light ray strikes a surface, the angle at which it hits the surface is exactly the same as the angle at which it leaves. This principle can be observed in countless scenarios, from the simple act of looking into a mirror to the complex designs of optical instruments. These angles are measured from an imaginary line perpendicular to the reflecting surface, called the normal. The normal line is crucial because it serves as the reference point for measuring both the angle of incidence and the angle of reflection. Without this reference, it would be impossible to accurately describe how light behaves when it encounters a reflective surface. Imagine shining a flashlight on a mirror. The light beam travels in a straight line until it hits the mirror. At the point of contact, the light beam changes direction, bouncing off the mirror and continuing its journey. This change in direction is governed by the law of reflection. The angle at which the light hits the mirror, angle of incidence, is the same as the angle at which it bounces off, an angle of reflection. This is true regardless of the angle at which the light strikes the surface. Whether the light hits the mirror head-on or at a steep angle, the law of reflection ensures that the angles of incidence and reflection are always equal. This law is fundamental to understanding how mirrors and other reflective surfaces work. It explains why we can see our reflection in a mirror, why a shiny metal surface can reflect light, and why sunlight sparkles on the surface of water. The law of reflection is a universal principle that helps us make sense of the world, from the smallest reflective surfaces to the vast expanse of the cosmos. Section 5. Smooth moves, specular reflection. Specular reflection occurs when light reflects off a smooth surface at a specific angle. This creates a clear, sharp image, like the reflection we see in a mirror. Imagine a still pond on a clear day. The smooth surface of the water acts like a mirror, reflecting the sky and surrounding scenery with remarkable clarity. This is specular reflection. Section 6. Rough around the edges, diffuse reflection. Diffuse reflection happens when light hits a rough surface. The light scatters in different directions. This results in a blurry or less distinct reflection. Think about a piece of paper. It might reflect some light, but you don't see a clear reflection in it. That's because the surface is rough. The light rays scatter, making the reflection diffuse. Section 7. Mirror, mirror on the wall. Mirrors are fascinating objects that utilize reflection. They come in different shapes, each with unique properties. A flat mirror, the most common type, creates a virtual image that appears to be behind the mirror's surface. Concave mirrors curve inward. They can focus light and make objects appear larger. Convex mirrors curve outward. They make objects appear smaller and provide a wider field of view. The magic of mirrors, from telescopes to cars. Mirrors have been an integral part of human innovation for centuries, playing crucial roles in various fields. From the vast expanse of space to the everyday commute, mirrors are everywhere. Mirrors have countless applications in our daily lives. They are not just tools for personal grooming, but are essential in scientific research, safety, and even in enhancing the aesthetics of our living spaces. The versatility of mirrors is truly remarkable. Concave mirrors are used in telescopes to gather and focus light from distant stars and galaxies. These mirrors are designed to collect as much light as possible, allowing astronomers to observe celestial objects that are millions of light years away. The precision and clarity provided by these mirrors are unparalleled. They are also used in makeup mirrors to magnify details. This magnification helps in applying makeup with precision, ensuring that every detail is perfect. The same principle of magnification is used in various other fields, such as in microscopes for scientific research. Convex mirrors, on the other hand, are often used as rear-view mirrors in cars. These mirrors are curved outward, which allows them to cover a wider area. This is particularly useful for drivers as it helps in reducing blind spots and provides a broader view of the road behind. Because they provide a wider field of view, they allow drivers to see more of the road behind them. This enhanced visibility is crucial for making safe driving decisions, such as changing lanes or reversing. The design of these mirrors is a perfect blend of science and practicality. Their ability to make objects appear smaller is beneficial for safety. By reducing the size of the reflected image, convex mirrors give drivers a better sense of distance and speed of the vehicles behind them. This feature is especially important in high-traffic situations where quick and accurate judgments are necessary. The journey of mirrors from early telescopes to modern cars is a testament to human ingenuity. Early astronomers relied on rudimentary mirrors to explore the heavens, while early drivers used basic mirrors to navigate the roads. Over time, advancements in mirror technology have significantly improved both fields. Today, we have advanced telescopes with highly sophisticated mirrors that can capture the faintest light from distant galaxies. Similarly, modern cars are equipped with mirrors that have integrated sensors and cameras, providing drivers with real-time information and enhancing safety. Beyond telescopes and cars, mirrors are used in a myriad of other applications. In technology, they are crucial components in lasers, cameras, and various optical instruments. In art, mirrors are used to create stunning visual effects and installations. The possibilities are endless. Whether in science, safety, or art, mirrors continue to play a vital role in our lives. Their ability to reflect light and images makes them indispensable tools in many areas. As technology advances, the applications of mirrors will only continue to grow, reflecting the endless potential of human creativity. Sparkling brilliance reflection in gemstones. Gemstones, like diamonds, owe their brilliance to a phenomenon called total internal reflection. When light enters a diamond, it bounces around inside due to its cut and the high refractive index of the material. This internal reflection causes the light to disperse into a spectrum of colors, creating the diamond's characteristic sparkle. The precise angles and proportions of the facets are crucial for maximizing brilliance. Trapped light total internal reflection. This captivating phenomenon is not just a trick of light, but a fundamental principle of physics that has practical applications in our daily lives. Total internal reflection occurs when light traveling through a denser medium, such as water or glass, hits the boundary of a less dense medium, like air, at a specific critical angle. When this angle is exceeded, the light doesn't just pass through, it is completely reflected back into the denser medium. This means that instead of refracting and passing into the less dense medium, all the light is reflected back, creating a mirror-like effect. This is why you might see a perfect reflection of the sky when you look at a body of water at a certain angle. One of the most remarkable applications of total internal reflection is in fiber optic technology. Fiber optic cables are used to transmit light signals over vast distances with minimal loss of signal. These cables are made of a core surrounded by a cladding with a lower refractive index. The light entering the fiber optic cable is kept within the core by total internal reflection, bouncing back and forth along the length of the cable. This allows data to be transmitted quickly and efficiently, making high-speed internet and telecommunications possible. The principle of total internal reflection ensures that the light signals remain strong and clear, even over long distances. Beyond fiber optics, total internal reflection is also responsible for the brilliance of diamonds and other gemstones. When light enters a diamond, it is reflected multiple times within the stone, creating a sparkling effect that is highly prized in jewelry. In everyday life, you can observe total internal reflection in various scenarios, such as the shimmering patterns of light at the bottom of a swimming pool or the way light behaves in a glass of water. This phenomenon not only enhances our understanding of light, but also enriches our visual experiences. Reflections on reflections, a final thought. Light reflection is a fundamental principle that shapes our perception of the universe. From the simple act of seeing our reflection in the mirror to the complex workings of telescopes and fiber optics, it plays a crucial role in our lives. Understanding the laws of reflection allows us to appreciate the beauty of a rainbow, the sparkle of a diamond, and the technological marvels that define our modern world.